C double bond O. This is generic way of writing it. C double bond O plus NH3. This is going to give you C double bond N bonded to H. Okay, C double bond N bonded to H plus H2. Fair. Now, if I have something specific, for example, CH3, CHO plus NH3, then in this case, this is going to give me CH3 single bond C with H double bond N H plus H2. Similarly, if I have a ketone such as this plus NH3, good evening, Akshay, plus NH3, then in this case, I'm going to get double bond N and bonded to H. Okay. So I hope all of you remember how to form the bonds, how to form the products when you have ammonia and ammonia derivatives. Please write this down. Right, next, B part.
Second roll.
Okay. Please let me know once you're done.
Done.
Right, next, reaction with amine. Amine is if you have NH2, this N is now bonded with some alkyl group R. So please write generic reaction C. Sorry. First of all, write it gives substituted amine. This is also known as Skiff's base. Right? C double bond O plus NH2R is going to give you C double bond N R CH3 CHO plus NH2R. This is going to give you CH3 single bond C double bond N R, and this will have a hydrogen like this. If you have a ketone, something like this, wait a second, यहाँ पे CH3 लिख लीजिएगा प्लीज. You also write CH3. So you'll get 2 carbon atoms. double bond N, and here you will get CS3. Get this down. Plus H2O will be there. In all of these ammonia derivatives, you will have H2O. Write it fast. After this, you will write reaction with hydroxyl. Reaction with hydroxylamine. It gives oxime. Generic reaction C double bond O plus NH2OH gives you C double bond N. C double bond NOH plus H2O.
Yes, you can scroll.
In this case, you're going to get CS3. You can also write it like this: CH double bond N OH.
अक्षय आप कल आए थे
When, sir?
yesterday
No.
were you there in the class?
No.
Why what happened?
Oh, I thought classes not there.
You thought class is not there, why?
No message came like saying classes there. So
मैसेज नहीं आया था आपको?
yes, sir.
तो आप पूछ लेते ना,
And
क्लास
also
कैंसिल
I was writing some like project works, so I thought maybe it's good. So I will see the
Practicals की-
recordings.
Sorry?
I will see the recordings.
हाँ, obviously you have to see the recordings. And practicals के dates आ गए क्या आप लोग के यहाँ?
I think it's on January.
1 जनवरी तो है, but
स्कूल अपने हिसाब से रखते हैं, राइट? आई मीन सीबीएसई तो
Yes.
ये नहीं देता है ना, स्कूल्स ने ऐसा अभी कुछ नहीं कहा है आप लोगों को, आई थिंक।
No, sir.
राइट, नेक्स्ट डी पार्ट। अब यहाँ से आप लोग खुद से कीजिएगा, ठीक है ना? आई विल नॉट राइट द प्रोडक्ट्स फ्रॉम हियर। रिएक्शन विथ हाइड्रोजीन NH2 forms hydrazone. Okay, so DONA in your script is from 23rd to 31st January. Okay, fine. Boards are starting from 15th Feb. Boards are starting from 15th Feb. But still we have not got the date sheet. 15th Feb में आपके पास starting में जो एग्जाम्स होते हैं इंग्लिश वगैरह से स्टार्ट होता है जनरली तो Okay, you will write the products on your own. Right, E part. With phenylhydrazine. Forms phenylhydrazone. Right, next. Reaction with 2,4 dinitro. Phenylhydrazine is also known as 2,4-DNP. It forms 2,4 dinitro. Phenylhydrazone. The structure of 2,4 dinitrophenylhydrazine is you have same structure like this NH2, NH, Then you also have the phenyl ring, but here you will have NO2 here, 2, and in the para position NO2. So in the product you will get C double bond N, NH, the phenyl ring like this. अच्छा एक चीज ब्रैकेट में प्लीज लिख लीजिए फॉर्म्स 2,4 डायनाइट्रोफिनाइल हाइड्रोजन दिस ऑरेंज इन कलर ऑरेंज रेड पीपीटी then write a note 2,4 DNP test is done for the detection of aldehyde and ketones. Compounds giving positive 2,4 DNP test may be aldehyde or ketones. Okay, so it is a confirmatory test for the carbonyl compounds.
If you see if there is a carbonyl compound, then it is going to give you, then it is surely going to give you the 2,4 DNP test.
Right, next. Reaction with semi-carbazide. Forms semi-carbazone.
So all of these reactions that we have done till now, all of these comes under the reaction of ammonia and ammonia derivatives. These are very similar reactions, only the Z is changing. The reaction pattern is all the same in all of these reactions. In this, the most important one is the 2,4-DNP test. That reaction comes in as a part of many of the 5 marks question. Okay, there is a compound A which gives 2,4-DNP test, and then it further reacts with this and that. So that type of question, they generally contain 2,4-DNP test. So please remember, the positive 2,4-DNP test is orange, red PPT. If there is a compound on reaction with 2,4-dinitrophenyl hydrazine, it gives orange red PPT, then it is either an aldehyde or a ketone. Okay, so this is a confirmatory test for the carbonyl carbon. Write this down, reaction with semicarbazide, and then we are going to do addition of hydrogen cyanide.
Now this is the second reaction of aldehyde and ketones. Addition of hydrogen cyanide, HCl. It forms cyanohydrin. It forms cyanohydrin. Right, next. Base is used as a catalyst. So first of all, we have HCN. Now from base, we'll have OH negative. This OH negative will attack on the hydrogen. This OH negative will attack on the hydrogen here, and it will give you CN negative plus H2O. Then the carbonyl carbon, C double bond O, this is having delta positive. Then you have CN negative. Okay, so CN negative, this carbon atom, it attacks on the carbon here. This pi bond breaks like this, leading to formation of carbon. The 2 bonds are as it is here. Those 2 bonds have not changed. You have O negative, and here you have CN. This bond is between carbon and carbon, okay? CN. Now, in the presence of water, O negative will abstract one of the water molecules, and it will give you the 2 bond as it is, OH and CN. If you want a specific reaction, then you have CH3, CHO plus HCN. In the presence of a base, OH negative. You'll have CH3, carbon. This carbon is going to get CN, double bond O, and it already had a H. Sorry. You'll get OH, and it already had a H here. This is cyanohydrin. If you have a ketone like this, the presence of OH negative, this oxygen atom will get OH. One of the carbon atoms here, it is going to get CN. Okay, this is also CH3, so CH3 as it is, and here you get a CN. After this, you all will write addition of sodium hydrogen sulfide. Addition of sodium hydrogen sulfide. So please see, you have C double bond O plus NaHSO3. So first of all, here, this sulfur atom, it attacks on the carbon because sulfur is going to have delta negative and Na is positive. So you first of all get carbon. This oxygen atom, it gets the ONA, and it also forms a bond with SO3H. And then there is a proton transfer. This proton transfer happens between this oxygen atom and this hydrogen. So this oxygen atom attacks the hydrogen, and there is a exchange of sodium and hydrogen between oxygen and sulfur part. So you'll have carbon, the two bond as it is. Here you will have OH, and here you will have SO3Na. Here you will have SO3Na. This is bisulfide addition product. Now, in general, if you have CH3, CHO plus NaHSO3, so you can directly write, now this carbon atom, which was having the carbonyl carbon. So this carbonyl carbon oxygen, it forms OH. Now, what was the bond here? This will be CH3. What is the other bond? Hydrogen. See this carbon atom here. This carbon atom, it is attached with CH3 and hydrogen. So CH3 and hydrogen, oxygen double bond oxygen, it becomes OH, and you get SO3Na. If you have some ketone like this, plus NaHSO3, here you will get OH, and here you will get SO3Na. The number of carbon atoms does not change. The reaction completely happens on the carbon that is containing oxygen. The carbonyl carbon is the reactive site here. Can I move on now? Right, next. The fourth one, addition of Grignard reagent. Now, addition of Grignard reagent we have already done in alcohol, phenols, and ethers. In the in the methods of preparation of alcohols, we have done addition of Grignard reagent. If you remember, if you have something like this, let's suppose, in general, the reaction will happen C double bond O plus some RMgX. So carbon atom is delta positive. This R group that is attached to magnesium, which is a metal, and it is going to give the electrons to the R group. So this will be delta negative. Now this is going to attach the carbon atom like this. Oxygen is going to get the electrons, and you will get the carbon atom, whatever bond was attached, it is attached as it is, the two groups. Here you have R, here you have O, and MgX. Then we added water, and as soon as we added water, what happened? We got C. Whatever groups are attached, they are attached as it is. This R from the Grignard reagent is present, and here O gets OH. So see, we had three different types of reaction. If I have formaldehyde in which carbon is only connected to hydrogens plus CH3MgBr first step, that dry ether, second step is H2O. Now in this case, this carbon atom will be connected to both of those hydrogen as it is. It will get a CH3 here, and it will get OH here. So formaldehyde, it gives what? Primary alcohol. But if one of the hydrogen is rather a carbon methyl group, C double bond O, CH3 MgBr. First step we are using dry ether. The second step we are using H2O as a solvent. Here everything is same, CH3 and hydrogen, they do not change. Oxygen gets converted to OH and this gets converted to CH3. We add a CH3 here. As you can see, hydroxyl group is connected to a carbon atom that is further connected to two different carbon atoms. So this is 2-degree alcohol. So formaldehyde, it gives 1-degree alcohol. Any other aldehyde, it gives 2-degree alcohol. And now if you have both of these carbon atoms, both of the groups are methyl or any other alkyl groups.
Sir, can you scroll up?
Scroll up. This much is fine.
Yes, sir.
First step is dry ether. Second step is H2O. The CH3s are as it is. The oxygen is OH now. And then you have one more CH3 that is coming from the Grignard region. So this is going to give you 3-degree alcohol. So formaldehyde, 1-degree alcohol. Other aldehyde, 2-degree alcohol, and ketones give you 3-degree alcohol when treated with Grignard reagent. For example, if you have something like this, so first step is CH3 MgBr. So identify the alkyl group that is present on the Grignard reagent, and then just add इसको OH कर दीजिए, and this carbon atom which was containing double bond O, that will get the Grignard reagent's alkyl group, that is CH3. Can we move on?
Yes.
Right, the fifth one. Addition of alcohols. Please write. First of all, regarding aldehyde. So please write aldehydes react with one equivalent of monohydric alcohol in presence of dry HCl to form alkoxy alcohol. Form alkoxy alcohol. Now, alkoxy alcohol, this is known as hemiacetal. Hemiacetal. This is an intermediate. So it forms alkoxy alcohol intermediate, which then reacts with one more molecule of alcohol to form gem dialkoxy alcohol. This is known as acetal. So please see what is happening here. We have aldehyde, we have R, C double bond O, and you have H. It reacts with R dash OH 1 equivalent. Okay, that means for each mole of aldehyde, there is 1 mole of, for each mole of aldehyde, there is 1 mole of alcohol. This happens in the presence of dry HCl. Now it gives, first of all, what? R. This R is as it is. This oxygen atom that is having double bond O, it gets converted to OH. The hydrogen is as it is. And here you get OR dash. So this is what, this is hemiacetal. Now this is an intermediate. It further reacts with 1 more mole of R dash OH. And this OH it also converts to OR dash. Here also we have OR dash, and then you have H. So see, you have dialkoxy, and in the same carbon atom, that is why it is gem. You have dialkoxy, and it is gem because it is on the same carbon atom. And here we have, this is gem dialkoxy alcohol. Okay? This is known as acetal. Now, similarly, for this you need 2 moles of alcohol, primary alcohol. Okay, if you have, this is monohydric alcohol. Also, one more thing, this is monohydric. That means only 1 hydroxyl group. But if you have C double bond O, R, and hydrogen plus ethylene glycol. Now, ethylene glycol is HOCH2, and these 2 carbon atoms are bonded to each other. So this is what? This is a mono. This is not a monohydric. This is a dihydric alcohol. This is not a monohydric alcohol. This is dihydric alcohol. And in this dihydric alcohol, the hydrogen of alcohol, they get taken away with this carbonyl carbon's oxygen, and you have R, CH, OCH2, and then there's a bond between both of these. And this is cyclic acetal. Now, ketones, they only react with dihydric alcohols. Is right? Ketones only react with dihydric alcohols to form ketals. You'll have C double bond O, some R group here, some R dash here, plus HOCH2 bonded with CH2, O and H. Again, this water molecule Both of these are happening in the presence of dry HCl. Dry HCl mat bhuliega. Dry HCl is here. Dry HCl, and we get R, carbon, R dash, OCH2, get a bond here. Acetals and ketals. Now, when you have acetals and ketals, and if you hydrolyze them in mineral acid, that means in the presence of H+, you add water to them, then you will get the parent aldehyde and ketones. Okay, so acetals and ketals give parent aldehyde and ketones on hydrolysis with mineral acid. Okay, so for example, if you have, let us suppose something like this: CH3, OCH3, OCH3, and here you have hydrogen. So this is what this is. This compound has been made from aldehyde. How can I know that? Because the alkoxy groups are attached to a carbon atom, which is further attached to hydrogen. So in the presence of H3O plus, this fragment will be same. जो alkoxy वाला नहीं है ना, that will be same. CH3, CH, and then on the carbon atom that was having the alkoxy groups, you will attach the C double bond O. Similarly, if you have CH3, carbon CH3, you have OCH3, OCH3, then again, anything that is not alkoxy, it is going to be what? It is going to be the part of the chain. So you'll have CH3, carbon, CH3. और इस carbon पे क्या लगा होता है? Alkoxy. So you will add the double bond O. Similarly, you have carbon, the CH3 groups here, oxygen with the CH2. Okay, so this is the cyclic ketal. This is CH3 and CH3. Okay. Here also we are going to get the same compound, acetones. Can you please write this down? This is also H3O plus.
Now, write the next topic, reactivity of aldehyde and ketones. Now, all of these reactions that you have seen right now, the above ones with alcohols, then with Grignard reagent, all of these are nucleophilic reaction. As you can see, यहाँ से start करते हैं. Even if you look at amines here, all of these nitrogens are what?
lone pair, and they are attacking on this carbon. Okay, all of these nitrogens. So you saw in ammonia, then if you saw in, you also saw this in cyanide. The CN negative is attacking on carbonyl carbon. Then you saw this on sodium hydrogen sulfide. Here the sulfur atom is attacking on the carbonyl carbon. Then you have in Grignard region, again, the attack is happening on the carbonyl carbon. Here also in alcohols, this is attacking on the carbonyl carbon. So all of these are nucleophilic addition reaction. Now we want to compare the reactivity of aldehyde and ketones towards nucleophilic addition reaction. So please write reactivity of aldehyde and ketones towards nucleophilic addition reaction. Towards nucleophilic addition reactions. Now, let us look at the structure of aldehyde. This is R, C double bond O, hydrogen, and ketone is R, C double bond O, some other group R dash. You have a nucleophile, and this nucleophile is going to attack on aldehyde and on ketone, but on the carbonyl carbon of aldehyde and on the carbonyl carbon of ketone. Now, if this carbonyl carbon has a high positive charge, then it is going to be easier for nucleophile to attack. And here, if it is having same in both of the cases, if the carbonyl carbon is having more positive charge, then it will be easier for the nucleophile to attack on this carbonyl carbon. But if you look at ketone, ketone has two different electron donating group, that is CS3 and CS3. Now that is why what happens, this carbonyl carbon is not as electrophile. It is not as electrophile as the aldehyde carbon. It is not as electron poor as the aldehyde carbon. One thing is that. The second thing is both of these groups that is attached to the reactive site, these are bulky group in ketones. Both of these are alkyl groups, and alkyl groups are bulky, and that is why there will be steric hindrance. So the number one reason that aldehyde is more reactive is less steric hindrance. Here it has more steric hindrance. Second reason is the carbonyl carbon is highly electron poor as it is attached to only one alkyl group, that is electron donating group. Here we will write the carbonyl carbon यहाँ पे इलेक्ट्रॉन पुअर है, ठीक है ना, आई मिस द वर्ड पुअर, इलेक्ट्रॉन पुअर लिखिएगा, is highly electron poor. Here you write for ketones, this is aldehyde, this is ketone. The carbonyl carbon is less electron poor as it is attached to two alkyl groups, to two electron donating alkyl groups, essentially electron donating groups.
Done everyone? Yes or no? Please tell me.
1 minute, sir.
Okay. Done, guys.
Done, sir.
Now, there is a specific problem that is between benzaldehyde and aliphatic aldehyde. Now, in aldehydes, which is more reactive, aliphatic aldehydes or benzaldehyde? Please write benzaldehyde versus aliphatic aldehydes. Now, in this, there is a question in NCERT specifically, तो उसी को लिखते हैं, but this is for all the aliphatic aldehydes. So you have benzaldehyde versus benzaldehyde propanol. Now, if you look at benzaldehyde, now this benzaldehyde, if this bond breaks, then there is a conjugation here, which is going to get the carbon a double bond again. So you'll have a double bond carbon, O negative, and here you have H. Here you will get a positive charge. These bonds will be as it is. But if you see propanol, you have CH3, CH2, C double bond O, and then you have H. Now, if this bond breaks here, then you will see CH3, CH2, CO negative, hydrogen, and a positive charge directly on the carbon that was carbonyl carbon. Okay, so as you can see in benzaldehyde, ab iske bare mein nahi likhe, which is more reactive, they will ask and why. So you will see that benzaldehyde, what is the carbon atom? The carbonyl carbon of benzaldehyde does not get pure positive charge, That is why it is what? That is why it is not very reactive. That is why it is not very reactive. Please write the carbon of, please write the carbon of carbonyl carbon in benzaldehyde is less electrophilic than the carbonyl carbon of propanol. The polarity of carbonyl group is reduced in benzaldehyde due to resonance. Okay, so two of the most important words here is it is less electrophilic and due to resonance. Please याद रखिएगा. Write a question. Compare the reactivity of following. Towards HCN. ठीक है ना, तो इस तरह से आपको ऐसे नहीं बोलेगा न्यूक्लियोफिलिक एडिशन रिएक्शन, दे विल गिव यू अ रिएजेंट HCN, they will give you sodium sulfate, they will give you alcohol, they will give you ammonia or ammonia derivatives, and they will ask you to compare. But you have to understand that all of these reactions are what? All of these reactions are nucleophilic addition reaction. So whatever we have conclusion from the above case, that aldehydes are most reactive, then we have ketones, and in aldehydes, aliphatic aldehydes are more reactive than benzaldehyde. So these reactions, all of these conclusions are what? All of these conclusions are also applicable in the HCN reaction or reaction with alcohol or reaction with ammonia, because all of those reactions are nucleophilic addition reactions only. So please write what we have to compare. Number one, acetaldehyde. Number two, acetone. Number three, di-tertiary butyl ketone, di-tert butyl ketone. And number four के लिए जगह नहीं हुआ. And number four is methyl tertiary butyl ketone. Methyl tert butyl ketone. सबसे पहले we will write the structure of all of these compounds. Acetaldehyde, CH3, CHO. Acetone, carbonyl carbon that is attached with 2 CH3 group. Di-tertiary butyl ketone will have carbonyl carbon. Now this carbonyl carbon is attached to tertiary butyl. So this is one carbon atom and 3 more carbon atom in the tertiary form. So this is di-tertiary butyl ketone. Here we have the ketone C double bond O. One is methyl group and the other group that is attached is tertiary butyl. Methyl tertiary butyl, methyl tertiary butyl ketone. Okay. So these are the different carbonyl compounds that we have to compare. So obviously, if I look here, I can first of all very easily say that first one will be the most reactive. Why? Because it is an aldehyde, and rest of all of these are ketones. So aldehyde have more reactivity than ketones. Now, then we look at ketones. In ketones, we can see that steric hindrance is one of the factors in ketones. It's the only factors we are going to compare the ketones within ketones. So here you can see that this is second one is having less steric hindrance. Then we have between 3 and 4. In 3, we have both the group tertiary butyl. So tertiary butyl means 4 carbon atom here, 4 carbon atom here. Here we have one group with 4 carbon atoms. The other group is only CH3. That is why fourth will be the next, and after that the least reactive is di-tertiary butyl ketone due to steric hindrance. Okay, so please write this down. This is how you are going to compare. First of all, जो aldehyde, see, the most reactive is going to be aliphatic aldehyde. Then you will have benzaldehyde. And after that, you are going to have ketone. And inside ketones, see bulky groups. If you have bulky group, that means bulky group hai, so reactivity is less in ketones. Similarly, in aldehydes also, if you have large bulky groups attached, then it is going to be what? It is going to be less reactive. But aldehydes are always going to be more reactive than ketones. Please write this down.
10, sir.
Right, next mechanism of nucleophilic addition reaction. Now, the mechanism of nucleophilic addition reaction is not very hard, it's very easy. First of all, you will have the carbonyl carbon. You will show the polarity. This is delta positive, this is delta negative. And then here you will keep the nucleophile. Nucleophile can have lone pair or negative charge, so you can put negative charge very easily. It attacks the carbonyl carbon like this. There is a see, this is a planar structure. Okay, na carbonyl carbon. You can see 1, 2, 3. Steric number is 3. That is why it will be trigonal planar. इस तरह से sp2 hybridized. And the trajectory which nucleophile uses in order to attack the carbonyl carbon, that is known as Burgi-Donitz trajectory. ठीक है, but that is not there. So आप ये ऊपर से दिखाइएगा न्यूक्लियोफाइल को यहाँ से, ठीक है, न्यूक्लियो या फिर आप इस तरह से दिखा सकते हैं नीचे से, इस तरह से, ऐसे मत दिखाइएगा न्यूक्लियोफाइल को, इस तरह से मत दिखाइएगा कार्बन कार्बन पे अटैक कर रहा है, ठीक है. सो इट आइदर अटैक्स फ्रॉम अबव और फ्रॉम बिलो, इस तरह से. यहाँ बीच से ऐसे अटैक नहीं करता, बस इसका ध्यान रखिएगा. देन इट इज गोइंग टू फॉर्म nucleophile like this. You have O negative, and here you have the other group. So these are the two groups, nucleophile, and then you have the oxygen. Then in the presence of H plus, the nucleophile is as it is, the two groups are as it is, and this oxygen will get OH. That's it. Okay. NCERT में आपके पास इस तरह से ना A और B करके लिखा हुआ है, कुछ यहाँ पे attached है. So if you want to write, you can write it like this also with A and B's. ये वाला भी आपका रिवर्सिबल टाइप से रहता है रिएक्शन. Now this first step is the slow step. Okay, the second step is very fast because it is acid base reaction. H plus को abstract कर रहे हैं. Once you're done writing that, you will write reduction of aldehyde and ketones. In this you will write the number 1. Reduction to alcohols. Now, these reactions we have learned in methods of preparation of alcohols. So please write, if you have a carbonyl carbon like this, with two groups attached, you can use 3 different reagents. One is LiAlH4, the other is NaBH4, and the other is H2 in the presence of PD, PT or nickel. All of these are going to give you whatever groups are attached, they will be attached as it is. The double bond will convert to single bond. Carbon will get 1 hydrogen, oxygen will get 1 hydrogen. Please write, aldehyde gives 1 degree alcohol. On reduction, ketone gives 2 degree alcohol. On reduction, Now, right next. This is important name reaction, Clemenson reduction. In this, carbonyl carbon of aldehyde and ketone gets converted to CH2 on treatment with zinc amalgam and concentrated HCl. डबल बॉन्ड O प्लस ऐसे जनरली आपको मिलेगा ये zinc Hg conc HCl. So what will happen? These groups are as it is. This becomes CH2. For example, if you have CH3CHO, zinc Hg and HCl, it will be CH3CH3. Okay, so if you have butane 2-1, it's going to get converted into just normal butane. What is the reagent? Zinc amalgam and concentrated HCl. Right, next, Wolff-Kishner reduction.
So 1 minute, can you scroll up?
Yeah, sure.
Let me know once you're done.
Yes, sir.
Done.
No, sir, I'll let you know.
Acha. Okay.
Done, sir.
Right, next. This is Wolff में double F या फिर single F, I don't remember actually. It's double F. Wolff-Kishner reduction. The product is same here also. Please write. बिल्कुल यही होता है इसमें भी. Carbonyl carbon of aldehyde and ketone gets converted to CH2, but the treatment is different. Please write. Carbonyl carbon. Then the carbonyl group of aldehyde and ketone gets converted to CH2 on treatment with hydrazine and further heating with KOH. Okay, so if you have C double bond O plus hydrazine, that is NH2 NH2. इसमें तो आप लोग को पता है, you will get double bond N, single bond NH. उसके आगे आप KOH and in heat you are going to get CH2. So if you have something like this, and in the first step you have NH2 NH2. Second step you have KOH with heat. This will become normal cyclohexane. Okay, so it becomes normal alkane.
Done everyone? Yes or no, please tell me. नहीं हुआ है अभी, लिखे आराम से लिखिए.